On April 8, 1945, soldiers of the 354th Infantry Regiment of the United States Army stormed the grounds of the Gotha aircraft factory, hidden at the very edge of the Thuringian forest in the small German town of Friedrichsroda. For 3 consecutive days, the Americans had been gnawing through the German defenses, losing men and running into ambushes. Finally, the factory was taken. But what the soldiers saw inside the workshops made them stop and fall silent. On the concrete floor stood 4 strange aircraft that looked not like planes, but like giant steel stingrays. These machines had no tail, no usual fuselage, only wings, huge, swept back, merging into a single body that concealed the pilot's cockpit and 2 jet engines. No one in the American military had ever seen anything like it. The infantrymen, accustomed to the sight of ordinary Messerschmitts and Focke-Wulfs, simply did not understand what was before them. Before them stood a weapon that could have changed the entire course of the air war if Germany had gained even a few more months. Command reacted instantly. Within just a few days, a special group from the 8th Air Force of the United States arrived at the factory, working as part of the top-secret Operation Paperclip. The task of this operation was simple and cynical: to seize all the most valuable German military developments before anyone else could, and primarily before the Soviet Union did. Specialists inspected all 4 machines, chose the most complete specimen, and ordered its immediate shipment to America. The other 3 prototypes were ordered to be destroyed on the spot, so that not a single sample would fall into the hands of the Soviet troops rapidly advancing from the east. Additionally, 75 miles from the factory, the American Army discovered a pair of huge wings manufactured for this same project. The wings were also loaded and sent across the ocean along with the fuselage for thorough study. America had gained a trophy that would define the future of world aviation for decades. But what was this aircraft, and how could something so fantastic be created in the ruined, bleeding Germany of 1945? To understand this, one must go back a decade and a half to the early 1930s, when 2 young Germans named Horten began their journey into aviation. Reimar and Walter Horten were brothers, and both had been obsessed with the sky since childhood. Reimar was a dreamer and a genius designer, one of those people who can see the shape of a future aircraft by closing their eyes. Walter was a daring pilot, ready to take anything his brother drew into the air, even if it looked like utter madness. Together, they formed a bond in which the designer's talent was backed by the test pilot's fearlessness. It was this partnership that allowed them to achieve the impossible. In those years, Germany, under the terms of the Treaty of Versailles signed after the defeat in the First World War, had no right to create a military air force. The ban was harsh and humiliating, but the Germans found a way to bypass it. So-called sports glider clubs began to open across the country, where formerly young people learned to fly harmless gliders, but in fact, the future military aviation of Germany was being forged. It was in these clubs that the Horten brothers began building their first flying machines, and it was there that Reimar first became fired up with the idea that would become the work of his life, the idea of the flying wing. The concept was both simple and revolutionary. An ordinary aircraft consists of a fuselage, wings, and a tail unit. But if you think about it, only the wings create useful lift. The fuselage is needed to house the crew and cargo. The tail is needed for stability and control. But both the fuselage and the tail create massive aerodynamic drag, slowing the plane down, consuming fuel, and adding weight. What if you removed everything unnecessary and left only the wing? Place the crew, engines, fuel, and weaponry right inside the wing, and replace the tail with a clever aerodynamic shape that provides stability itself. Such a plane would be lighter, faster, more economical, and could fly further than any counterpart with a conventional layout. It sounds like science fiction, but Reimar Horten was convinced it was possible. Throughout the 1930s, the brothers built a whole series of experimental flying wing gliders, each becoming more complex and advanced than the last. They learned from their mistakes, refined the aerodynamics, and searched for that perfect wing shape that would allow flying without a tail. By the early 1940s, when Germany was already waging a world war, the Horten brothers had accumulated unique experience that no one else in the world possessed. They knew how to make a flying wing work. They only needed a chance to prove it, and the war provided that chance. By 1943, the situation in the air over Germany had become catastrophic. Thousands of heavy Allied bombers were turning German cities into ruins day and night. Factories, power plants, and railway junctions were all methodically destroyed by carpet bombing. The Luftwaffe had almost nothing left to stop this fiery conveyor. Fighters with piston engines were becoming hopelessly obsolete, and anti-aircraft artillery could not cope with the armadas flying at high altitudes. Germany needed something fundamentally new, and it needed it urgently. It was then that Reichsmarschall Hermann Göring, who commanded all the air forces of the Third Reich, announced a competition that went down in aviation history under the short and punchy name 3x1000. The requirements sounded simple, but behind this simplicity lay an engineering task on the brink of the impossible. Göring wanted an aircraft capable of carrying 1,000 kilograms of bombs over a distance of 1,000 kilometers at a speed of 1,000 kilometers per hour. Each of these requirements individually was a serious challenge, but all three at once seemed like a fantasy. 1,000 kilometers per hour in 1943 was a speed inaccessible to any serial aircraft in the world. Only jet engines could achieve it, but they devoured kerosene at a monstrous rate, making the range requirement almost impossible to fulfill. It was a closed circle. To fly fast, you need jet motors, but to fly far on jet motors, you need so much fuel that the plane becomes too heavy and slow. One after another, German aircraft designers refused to participate in the competition, admitting the task was unsolvable with existing technologies. But the Horten brothers saw these requirements not as a dead end, but as a confirmation of their convictions. All their years of experiments with the flying wing led to this very moment. A machine without a fuselage and tail has such low aerodynamic drag that with the same engines, it will fly significantly further than a conventional aircraft. The fuel saved on overcoming frontal resistance turned into those missing kilometers of range. The flying wing was the only configuration capable of even theoretically reconciling jet engine speed with a flight range of 1,000 kilometers. Reimar and Walter submitted their project, and it turned out to be the only one of all those proposed that even approached meeting Göring's requirements. The Reichsmarschall was impressed. The Horten brothers received 500,000 Reichsmarks and an order to build several prototypes and get them into the air as quickly as possible. For a warring Germany already experiencing a shortage of resources, this was a huge amount of money and a huge amount of trust. Now they had to justify it with action. The aircraft the brothers began to design was completely unlike anything existing in aviation at that time. If viewed from above, it resembled a giant bat with a wingspan of 16.8 meters. The length along the central axis was only 7.4 meters, and the total height did not exceed 2 meters 81 centimeters. The pilot's cockpit, recessed into the central part of the wing, was so cramped that the pilot's helmet literally pressed against the canopy. The height of the cockpit was only 1 meter 10 centimeters, and only one person could be in it. But the Horten brothers did not need comfort. They needed speed. The key engineering solution was the shape of the wing. Reimar developed the so-called bell-shaped lift distribution, which NASA specialists would call brilliant decades later. The essence was that the wing was long and thin with high aspect ratio, and its profile changed from the center to the tips according to a special law. This shape solved two problems at once that had plagued all previous attempts to build a flying wing. First, it provided stability without a tail unit. The The plane did not yawn from side to side and did not tend to fall into a spin. Second, it radically reduced induced drag at the wingtips, which added both speed and range. But the real surprise was the materials. In conditions of a total shortage of metal and resources, when Germany was literally suffocating under bombardment, building an all-metal aircraft was impossible. The Horten brothers found a way out that proved to be not just a forced measure, but an unexpected technological breakthrough. The wings were made of plywood, impregnated with carbon dust, and glued together with a special compound based on sawdust and charcoal. It was cheap, accessible, and surprisingly effective. Much later, already in the 21st century, researchers would discover that this carbon impregnation absorbed radar waves, making the aircraft significantly less visible on radar screens. The Horten brothers did not consciously design a stealth aircraft, but they accidentally created a technology that the rest of the world would not reach for another 40 years. As a power plant, two Junkers Jumo 004B turbojet engines were chosen, each with a thrust of about 883 kilograms. They accelerated the machine to a maximum speed of 960 kilometers per hour and provided a range of 1,900 kilometers, which was almost double Göring's requirements. The practical ceiling reached 15,000 meters, and a brake parachute ejected from the tail section of the wing was used for landing. The armament consisted of two 30mm cannons, which, according to German military calculations, were sufficient to destroy heavy bombers. The machine was ready to fly, and now the word was with the test pilots. The first prototype, designated V1, was built without engines. The jet motors intended for this machine turned out to be too large and simply did not fit into the thin wing profile. The Horten brothers decided not to wait for motor modifications and used the first specimen as a glider to test aerodynamics and controllability. On March 1, 1944, at the Oranienburg airfield near Berlin, this strange, motorless apparatus first rose into the air being towed by another aircraft. The pilot detached the cable and found himself alone with a machine that flew contrary to all familiar laws of aviation. No tail behind, no fuselage beneath his feet, only a wing rushing over the flight field. A series of glider tests continued throughout the summer of 1944, and the results exceeded even the designer's boldest expectations. The machine was stable, obedient in control, and demonstrated magnificent flight characteristics. The bell-shaped wing profile worked exactly as Reimar Horten had calculated. While the glider was proving the viability of the concept in the skies over Oranienburg, the assembly of the second prototype, V2, was in full swing on the ground. This specimen was already equipped with two turbojet engines, and it was the one that had to prove that a flying wing was capable of not just soaring, but racing at near-sonic speeds. An experienced test pilot, Lieutenant Erwin Ziller, one of the few Luftwaffe pilots with significant flight time on jet machines, took the controls. On February 2, 1945, Ziller taxied onto the runway, gave full throttle to both engines, and lifted the machine into the air. What happened next impressed even seasoned aviation engineers. The flying wing climbed with a roar, easily accelerated, and demonstrated maneuverability that no one expected from an apparatus of such an unusual shape. Ziller spent about 2 hours in the air, performing various flight modes and checking controllability at different speeds. According to available data, it was during this period that the Germans conducted a comparative test of the flying wing against the Messerschmitt Me 262 jet fighter, which was considered the pride of the Luftwaffe and Germany's most advanced combat aircraft. The result of the comparison was staggering. The Horten demonstrated better controllability than the Messerschmitt. For a machine built of plywood and glue in semi-artisanal conditions, this was a fantastic result, confirming the correctness of all the calculations Reimar had made over the last 10 years. Göring was ecstatic. The Reichsmarschall immediately signed a contract for the production of 40 serial machines. 20 of them were to be single-seat fighters capable of intercepting Allied bombers at high altitudes. The pilots of these machines were to wear special high-altitude suits from the Draeger Company, as the working ceiling of 15,000 meters was far beyond the limits of the human body without additional equipment. The machines were also equipped with an ejection seat, which was a rarity for aviation in those years, and a brake parachute to shorten the landing run. The emergency mass production program was launched on March 12, 1945, when less than 2 months remained until the end of the war. But 16 days earlier, a tragedy occurred that dealt a terrible blow to the project. On February 18, 1945, Erwin Ziller took the V-2 prototype up for another test flight. Everything was going normally until, at a certain stage, one of the 2 engines failed. The Jumo 004 jet motors were temperamental and unreliable units, suffering from chronic problems with turbine blades, and the failure of one of them was not unexpected. But landing a flying wing on one working engine turned out to be a task for which even such an experienced pilot as Ziller was not prepared. The machine with asymmetrical thrust began to veer to the side, and Ziller was unable to level it. The aircraft crashed to the ground and was destroyed on impact. The test pilot died. Ziller's death was not just the loss of a brave man. Along with him, the only flying specimen with engines was destroyed, and along with the specimen, priceless data on the machine's behavior under jet thrust. It seemed the project was doomed, but Göring, contrary to logic and common sense, reacted to the disaster in a completely unexpected way. He did not close the program. On the contrary, he increased the order by another 20 machines, bringing the total number to 60. Production was urgently moved to the Gotha factory in Friedrichsrode, away from the front line. The Germans were desperately clinging to the last hope of turning the tide of the air war, even if that hope was made of plywood and flew without a tail. Feverish work began at the Gotha factory in Friedrichsrode. Engineers of the Gothaer Wagenfabrik Company, who previously produced railway carriages and in wartime switched to aircraft production, received the Horten brothers' drawings and began adapting them for mass production. The point was that Reimar's original projects were the work of a lone genius, intended for individual manual assembly. Mass production required serious structural reworking, simplification of technological processes, and standardization of parts. Gotha engineers worked on this while simultaneously assembling new prototypes, and several machines for different purposes were being built at the factory at once. The V-3 prototype was the most advanced of all. It was equipped with improved Jumo 004C engines, which were more powerful and reliable than their predecessors that had killed Ziller. For the first time, a full-fledged pilot ejection seat was integrated into the design, which none of the previous specimens had. Essentially, V-3 was to become the standard for the serial single-seat fighter, the very interceptor capable of climbing to 15,000 meters and attacking formations of heavy bombers with its 30mm cannons. But the Germans did not intend to limit themselves to one fighter variant. The V-4 and V-5 prototypes were designed as 2-seat machines. Unlike the single-seat interceptor, they were intended as all-weather night fighters, capable of operating in darkness and difficult meteorological conditions. The second crew member was to work with the onboard radar station, detecting targets in zero visibility. Night bombings were a real scourge for German cities, and while daytime raids could somehow be countered with anti-aircraft artillery, bombers operated almost with impunity at night. A 2-seat Horten with a radar on board could have been the answer to this threat. The V6 prototype returned to a single-seat layout, but differed from V3 by having reinforced weaponry. The German military wanted a machine with more powerful cannons capable of guaranteed destruction of 4-engine bombers with 1 or 2 bursts, without wasting time on long pursuits and repeated passes. Every second in a battle against a tight formation of bombers, bristling with dozens of defensive machine guns, could cost a pilot their life. Therefore, maximum firepower with minimum contact time was an absolute priority. Parallel to the factory bustle in Friedrichsroda, plans far more ambitious than just defending the German sky were unfolding in the offices of Berlin. The Luftwaffe leadership viewed the Horten not only as a fighter interceptor, but as a foundation for a whole family of next-generation aircraft. If the machine proved its effectiveness against bombers, why not go further? The flying wing, with its fantastic range and low radar visibility, could have become the ideal platform for a strike aircraft capable of delivering a bombing raid on England and returning to base without refueling. And if the design were scaled up, the size increased, and more powerful engines installed, one could theoretically aim for targets on the other side of the Atlantic. The 1,900-kilometer range of the basic fighter version left a colossal margin for growth as the machine's size increased. The idea of a transatlantic bomber was not pure fantasy. German command was seriously developing the so-called America bomber, a project for an ultra-long-range aircraft capable of reaching the east coast of the United States. Several design bureaus offered their versions, but they all suffered from the same problem: the monstrous fuel consumption required to cover thousands of kilometers over the ocean. The Horten brothers' flying wing, with its minimal aerodynamic drag, looked like the most promising basis for such a machine. If Germany had been given enough time, the technology could have gone far beyond the fighter interceptor, but Germany had no time left. By March 1945, the front was cracking at every seam. From the west, American and British armies were advancing, having crossed the Rhine. From the east, Soviet troops were coming like an unstoppable avalanche, grinding down the remains of the German defenses. The Allied bombers, the very ones the Horten was intended for, continued to destroy German industry day after day. Factories producing components for the flying wing one by one went out of operation or fell into the combat zone. Transport communications were destroyed, material supplies ceased, and qualified workers went to the front or died under bombs. The emergency fighter production program, which included the jet Heinkel He 162 Salamander alongside the Horten, stalled in all directions. The Heinkel at least managed to reach combat use, albeit in minuscule quantities. The Horten, however, fell hopelessly behind, and not a single serial specimen ever took to the sky. The steel ring around the Third Reich was tightening every day, and the plywood miracle of the Horten brothers had only weeks left to live. While American infantry stormed Friedrichsroda, another hunt for the secrets of the flying wing was unfolding on the other side of the front. The British Combined Intelligence Objectives Subcommittee, operating parallel to the American Operation Paperclip, conducted its own search for German aviation technologies. On June 11, 1945, 2 months after the surrender of Germany, British intelligence officers discovered a true treasure in the town of Treuewein on the Neckar River, approximately 100 kilometers southwest of Stuttgart. On trailers camouflaged between trees stood 3 fully equipped gliders designed by the Horten brothers. All instruments were in place, all control systems preserved, and documentation neatly laid out nearby. Someone among the German technicians had clearly taken care to ensure the machine survived the chaos of the final days of the war intact. The British carefully inspected the find and compiled detailed reports, but ultimately decided to hand over all 3 gliders to the Americans. The machines were loaded and sent across the ocean to Wright Field in Dayton, Ohio, where the main trophy, the V-3 prototype from the Gotha factory, was already located. Wright Field was the center for studying captured foreign aviation technology, and everything of interest found by the Allies on the territory of the defeated Third Reich was brought there. Specialists from the Foreign Aircraft Evaluation Branch received a unique set, a jet flying wing and a set of gliders of the same design on which they could practice piloting the unusual layout without risk. American engineers took the V-3 apart literally to the last screw. Every element of the construction was measured, weighed, photographed, and described. Of particular interest was the wing skin, that very plywood with carbon impregnation, glued with a compound based on sawdust and charcoal. The Americans quickly realized that this cheap material possessed properties that the Horten brothers themselves might not have fully suspected. The carbon impregnation absorbed radar waves, specifically at those frequencies used by Allied radars. The plywood plane from ruined Germany turned out to be the first aircraft in history with elements of radar visibility reduction technology, albeit created not intentionally, but out of necessity due to the lack of aluminum and steel. The data obtained landed on the desks of designers who were already working on their own flying wing projects. One of them was Jack Northrop, an American aviation engineer who had been following the Horten brothers' experiments with their sports gliders since the 1930s. Northrop was developing a heavy bomber using the flying wing scheme under the designation XB-35. It was a massive machine with propeller engines, and it suffered from powerful vibrations that could not be overcome. The project was stalling, and the data obtained from studying the trophy, Horten came at just the right time. Later, the XB-35 was modernized by replacing the piston engines with jet ones, and the machine received the new designation YB-49. The Horten brothers were right all along. The flying wing truly revealed its potential only with jet thrust. But the world only saw the true embodiment of Reimar and Walter Horten's ideas decades later. In 1989, the Northrop Company, successor to Jack Northrop's work, flew the B-2 Spirit strategic bomber. This aircraft, which became a symbol of American military power at the turn of the century, was designed using the flying wing scheme. Its smooth contours, lack of a tail unit, and the combination of aerodynamic perfection with stealth technology. All of this was a direct continuation of the line started by two German brothers in glider clubs in the 1930s. The resemblance between the plywood Horten of 1945 and the titanium B-2 of 1989 was so obvious that aviation historians directly called the German machine the progenitor of the American stealth bomber. Actually, the idea of a flying wing did not belong only to the Horten brothers. German aviation engineer Hugo Junkers patented the concept of an aircraft without a tail and fuselage back in 1910, 2 decades before the first experiments of Reimar and Walter. The Horten brothers took this idea and brought it to a completely new level, creating the world's first jet-flying wing. And 44 years after the plywood prototype crashed along with Erwin Ziller at a German airfield, their legacy rose into the sky in the form of the most expensive and technologically advanced combat aircraft on the planet. If you like this story, give it a like and write in the comments what other secret weapon of the Second World War you would like to hear about. And be sure to subscribe to the channel so you don't miss the next episode.